Namaste and welcome everybody to the Transitional Artificial Intelligence Research Group Seminar Series. This week we have Xue Chun Wang, and she's a graduating master's student by coursework thesis. And the topic is machine translation versus human experts for Chinese Mandarin using sentiment and semantic analysis. And she was supervised by me and Dr. Rodney Beard, who has joined all the way from Canada. And you can begin. Thanks.
Okay, so hi everyone. So my name is Xuchun, and today I'll present my project, the machine translation versus human experts for Chinese Mandarin using sentiment and semantic analysis. And yeah, obviously, the project is supervised by Dr. Rohit and Dr. Rodney. So now I'll introduce the background and literature.
Right.
Yeah, okay. Should I continue?
Yes.
Okay. So I'll introduce the background and literature review first, and then I'll present a framework diagram and I'll give an evaluation of results from sentiment analysis and semantic analysis. And finally, I'll discuss the major limitations and future work and make a conclusion at the end. So firstly, I'll talk about our aims of the project. We want to evaluate the quality of translations by Google Translate compared to the translations by human experts in sentiment and semantic perspectives. So firstly, I'll give a brief overview about the machine translations. So there are two types of the machine translations are popularized today. So first one is the rule-based machine translations. It's based on the syntactic, morphological, contextual, and semantic analysis perform machine translations from source languages to target languages. But it do have some difficulties, for example, like time consuming and its complexity. And the second machine translation model is statistical machine translation models. So it relies on the data-driven approaches, learns how to translate from the one language to another languages by using probabilistic models trained on the bilingual text corpora. But it still has some difficulties. For example, it may perform poorly with limited data. So now I'll introduce the Google Translate, since it is investigated as machine translation model in our study. So Google Translate is a statistical machine translation model. So it brought the Mandarin Chinese into automatic translation engines. So including the online search, e-learning, and social media. Also, it was investigated in the area of medical communications, scientific articles, and academic papers, etc. So in our study, we used the dataset originally in Mandarin Chinese. We aim to evaluate the quality of the Google Translate translations of a novel from Chinese to English. So in terms of Mandarin Chinese, it is spoken by more than 1.1 billion people in the world, and it is the second most spoken languages in the world after English, and is a subject, verb, object languages for both Chinese and English. We'll next talk about our dataset. So first is SunWave dataset. It's used for fine-tuning the BERT model in sentiment analysis. It contains the 10,000 tweets with 5 languages, and there are 10 sentiments included. And another dataset is the True Story of Aki, which is a novel that used as the original text. It consists of 9 chapters. So Google Translate will translate the original text to a translated version in English. And also we'll have two human experts version used to compare with the Google Translate one. So here is the two human experts translations. One is translated by Xian Yi and Gladys in 1953, and one is translated by Julia in 2009. Next, I'll introduce our models. So we use the fine-tuned BERT models to predict the sentiments of our three translations. It is a pre-trained large language models that employs the transformer deep learning model. It captures the richer contextual information due to its bidirectional feature. So the bidirectional feature is basically is read simultaneously from the left to right and right to left. And for the semantic analysis, we use the MPNet based model. It's an advanced sentence embedding model which performs the high quality sentence embedding. It encodes the verses and computes the cosine similarities. And here's my detailed data pre-processing steps. So first is to opening the PDF files and reading the content of each chapter. And next is to removing the chapter numbers, chapter names, and annotation numbering from each chapter. And finally is to separate each chapter, giving us paragraph to a single line so that we can implement sentiment analysis based on the sentences rather than a paragraph. And next I'll talk about the experimental and technical setup for the BERT model. So we use a pre-trained BERT-based uncased model and fine-tuned the model on the SenWave dataset with a dataset of 10,000 tweets by using batch size of 1 and 4 training epochs. We also implemented regularizations by using dropout layers with a probability of 0.3 dropout. We used a linear activation layers at the output for predicting the 9 sentiments present in the SenWave dataset. Next, I'll introduce our framework diagram. So in the stage 1, the data acquisition stage, we scrapped and collected the original text and human translations on the internet and saved as PDF files. Afterwards, in stage 2, we apply a data cleaning step and translate the original text via the Google Translate API. Moreover, in stage 3, we use the fine-tuned BERT models to implement the sentiment analysis, also employ the sentence embedding models to observe the similarities between the 3 translations. So in stage 4, we visualize the sentiment analysis and Jaccard results and compute the Jaccard similarity scores to evaluate the quality of the Google Translate translations in the sentiment analysis perspectives. Furthermore, we present our cosine similarities for comparing the selected pairs of 3 translations. Next is our evaluation of results parts. First, I'll start with the data analysis. So to investigate the theme of the original text, we utilize the n-grams in 3 translations. So in figure B here, it is a backgrams and trigrams for Google Translate. It demonstrates the Revolutionary Party, fake foreign devils are most mentioned consecutive words. It reflects elements such as devil as themes in Google Translate version and indicate a negative tone in the Google Translate translations. So the keywords of bigrams and trigrams in figure A and figure C have a high similarities. It further demonstrates that the 2 translations, those 2 translations by all human experts translators are relatively similar in their use of the keywords. Next, I'll discuss about the cumulative sentiment analysis across the 9 chapters. So as we can see in figure 3, we observe that thankful, empathetic, denial are the least expressed sentiment across the 3 translations. And the leading word the leading sentiments are showing in here. It's noticeable that the sentiment annoyed is underexpressed by Google Translate, and the joking is overexpressed by Google Translate. The 3 translations have similar understanding of sentiments. However, the predicted sentiment in translations by human experts is relatively closer to each other compared to the Google Translate. So those are the chapter-wise sentiment analysis from chapter 1 to chapter 3 across the in three translations. As we can see, annoyed and joking are over-reported in all the 3 translations. So furthermore, I'll present the top 10 optimistic and pessimistic diagrams and trigrams of 2 human experts translations. So in our figure, the top subfigure is the n-grams for Xianyi and Gladys, and the bottom subfigure is for Julia. To observe the overall feature, like the features that the true story here and the real stories are the most mentioned pessimistic words across the 2 translations. It's interesting to mention that the true story is in the title of the Xianyi and Gladys translation, and the real story is in the title of the Julia's translation. Since they are extracted to the top 1 pessimistic permutations, it goes further to indicate that thematic genre bring a pessimistic tone across the whole story for both 2 translations. So moreover, since joking and annoyed are over-reported across 9 chapters, we'll also show the top 10 joking and annoyed backgrounds and trigrams in 2 human experts translations in order to evaluate the keywords of joking and annoyed sentiment. So in overall, it's interesting to note that the imitations foreign devil is the leading words in both joking and annoyed sentiments for Xianyi and Gladys version. And fake foreign devil is the leading words in both joking and annoyed sentiments for Julia. It further illustrates that the expression in terms of joking and annoyed by 2 human experts translation are generally similar, which means the 2 translations is similar in sentiment analysis. We also aims to evaluate whether the sentiments of each chapter is in 3 translations are positive, negative, or neutral. Therefore, we visualize the mean of the sentiment polarity score in 3 translations by 2 methods. So first method is to custom the weight of the sentiment to compute the polarity score. And the second method is use the text blob Python library to compute the polarity score across the 9 chapters. So by observing the figure 7, it's interesting to note that the mean of the polarity score across all chapters are mostly negative, except the Google Translate translations. This demonstrates that the 2 human experts translations have a similar overall understanding for the original text in sentiment perspectives. However, the polarity score of Google Translate's version deviates from the 2 human experts version. Moreover, in figure 8, the mean of the polarity score in 3 translations are different. The translations by 2 human experts show a downward trend from chapter 8 to chapter 9 in both figure 7 and figure 8. This reflects that Aku, the main character in the novel, involved in the revolution and finally become the victim for the revolutions and being executed in the chapter 9, which leading to a tragic end. Next, for investigating the further sentiment analysis in 3 translations, we compute the Jaccard similarity. So generally, similarity score of the selected pairs with Google Translate version are not as high as the selected pairs of 2 human experts version. Therefore, the Google Translate's translations are sentimentally less similar compared to the 2 human experts translations. Next, we move to semantic analysis. We present a cosine similarity score and giving our standard deviations. It should be mentioned that the average score of the selected pairs with Google Translate translations is generally lower than the selected pairs by 2 human experts translations. We then present some of the semantically most similar verses by using the cosine similarity score in Table 4. In Chapter 9, verse 43, it's interesting to note that the verses from Xianyi and Julia are exactly same here. The choice of the words from Google Translate is also same as the 2 human experts translations. However, there is an extra December in the verse. In chapter 7, verse 38, and chapter 4, verse 20, so all 3 translations have utilized some or same or similar words such as quickly, pipe, stood up. Therefore, all selected pairs have obtained a high scores. So in addition, we present some of the semantically least similar verses by using the cosine similarity in Table 5. So in Chapter 7, verse 8, Chapter 3, verse 22, we observe that the choice of the words for mimetic word is different for all 3 translations. Moreover, for Chapter 9, verse 36, Chapter 8, verse 19, the Google Translate expressed the different meaning due to its lack of the contextual and the logical significance. Therefore, the selected pairs with Google Translate has a low cosine similarity. So chapter 2 is one of the important chapters in our novel, since it describes the characteristics of RQ and is the beginning of the story. We arbitrarily select 3 verses to compare their similarity scores. So in chapter 2, verse 7, as we can see, the Google Translates versus Julia and Xianyi versus Julia has much lower similarity than Google Translate versus Xianyi. We can infer that the Julia's translations of this verse exhibits a significantly semantic differences compared to the Google Translate version and Xianyi's version. And for the chapter 2, verse 16, so Google Translate versus Julia is semantically most similar, as evident by its cosine similarity score. So the passage describes betting on the passage. It is a phrase used when placing a bet. We should use the preposition on instead of in. If changed, the meaning of the sentence would be different. For chapter 2, verse 21, the sentence here, and it was him, now is gone. It said that he was taken away by his son, and he was always unhappy. Is inaccurately translated by Google Translate. The original text describes that although the money might have been stolen by his son, he still felt uncomfortable. For both 2 verses, Google Translate is enabled to understand the context of the word and lack of contextual significance. Therefore, The cosine similarity with the Google Translate is lower than the cosine similarity of two human experts' translations. We also have some further analysis to evaluate the quality of the translated text from Google Translate in semantic perspectives. The first example is Google Translate struggles to accurately break a sentence from original text. So the bold character means cheering up. However, Google Translate only translate one character, which is and ignore another one. The Google Translate translates the first character as string. So due to its wrong break in sentence, the meaning of the whole sentence is wrong. So for the two human experts' translations, they are significantly express the meaning of the verb. So second example is Google Translate enabled to express the meaning of the Chinese traditional allusions. The bold allusions implies that misfortune may lead to good outcomes, or good fortune may conceal adverse consequences. So in our verse, Lu Xu want to express that although the RQ couldn't continue gambling due to the lack of the money, it actually avoid him to lose more money, which turned out to be a good thing for him. But Google Translate only translated the pinyin, which is the spelling sound of the allusion, instead of their meanings. Therefore, Google Translate does not significantly express the meaning of the Chinese traditional allusions due to its lack of the contextual significance and the lack of the historical knowledge about ancient China. So to the end of the presentations, I'll give some points towards to the limitations and future works. So first, the major limitations in our study is we only used one type of the text, which is novel in our study. And it's inadequate sentiment in utilized data set. And the limited machine translation models, which we only used Google Translate in our study. And also we only used Mandarin as our source languages. So we also have the limitations in the language evaluations. So for the future work, we could use the various types of text, such as newspaper, academic paper, etc. We also can evaluate the machine translation by other languages. And also we can evaluate other machine translation models, such as Gemini or GPT model. So finally, based on our results, we could conclude that the counts of the predicted sentiment among three translations are not vastly different. The sentiment or semantic similarity between Google Translate and the human experts translations is not as high as the similarities between the translations of the two human experts. The differences in the sentiment by the different translators shows biases of transitions, and also the unique style of vocabulary and words used to capture the various situations. And Google Translate sometimes enable to break Chinese sentence properly. And it is inability to maintain the contextual connections. And lack of the contextual significance and historical knowledge for translating Mandarin. And this is our GitHub link. And this is the end, the whole presentations. Thanks for the listening. Should I show the GitHub?
Yes, please.
Okay, so here is the GitHub. I'll start with the README file. So I wrote this description of the project and description of the dataset here, and also mentioned the models that we used. And I put the framework diagram here. And I also added some hyperlinks, which if you click that, it will jump into the folders. And here is the visualization part, which is our result part. So this is our data set. So we do have 3 folders for our data set, and it is stored, it is saved as chapter wise. So this one is for the Google Translate, and there's the English verse for Google Translate in chapter 1 and chapter 2 and until the chapter 9. And this is for the Xianyi and Gladys version. And this is for the Julia's version. And this is.
How about the original data set?
Oh, I didn't put the original data set here.
Yeah,
but
yeah.
Yeah, I'll put later, like.
Right, yeah. We need the original data set, probably the PDF file of the actual
Okay.
Mandarin, so that could be read by the data processing.
Okay. And this is the Jupyter notebook for the data pre-processing part. And here is the sentiment analysis part. So we use the pandas library, and we use NumPy, and we use the matplot for the plot for the visualizations. Yeah, and here's the model part here. And also in the semantic analysis, we also use the NumPy library, pandas, and also we use the sentence transformer libraries here. And I use some stop words, which is to avoid the biases. And for the results parts, we also have 3 folders. The first folders is the polarity score. The second folder is sentiment analysis, and the third folder is semantic analysis. And also we do have a folder for the sentiment prediction. So, for example, we have all this predicted sentiment in here. Yeah, I think that's pretty much it.
Okay, thank you. Okay, all right. Thanks, Shu, for excellent presentation. Now we open the floor for questions and comments.
Yeah, if that's okay.
If you could come here, that would be great. Yeah.
Yeah.
Can you hear me, Shun?
Yeah.
Excellent. Thanks for the great presentation. I was curious about what the final performance of your sentiment classifier was, because one thing that people might question is how informative is those sentiment classifications of the text without knowing the performance of the model you trained?
Like the sentiment analysis part.
Yeah, so you trained a BERT model to do the sentiment classifier, but you didn't present results on how accurate that sentiment classifier was.
Oh yes. Yeah, I do have a file for the test on the SendWave dataset, but I haven't uploaded on the GitHub. But yeah, we definitely used like the F1 score or like to test the accuracy of the predicted sentiment.
Yeah, awesome. Okay, yeah, so it'd be great to see that. Now, the other
Yeah.
point I want to make is more of a commentary. I like all of the examples where you sort of dug in and looked at the specific pieces of language that were being mistranslated or disagreeing. I wonder whether there's a possibility to do something more systematic in that space. So, for example, I know with, say, the Spacey NLP library, you can process text into its linguistic grammatical structures. So it will tell you if it's basically noun phrase, verb phrase, noun phrase. So abstract classifications of the structure of a piece of text. You could look at categorizing each of the blobs of Chinese text into these abstract categories and then look if there's a certain type of grammatical structure that Google Translate tends to get worse, or what kind of constructs do you see the most disagreement between Google Translate and the human translators?
Yeah, fully agree.
Yeah.
Extension. Thanks,
Yeah,
John.
thank you.
Yeah. Thank you.
Right.
Can I just add something to that?
Yes,
Um,
Rodney.
so the example with drinking and shouting is a good example of that, because the second character that is used there doesn't actually have a meaning. It's essentially it's a particle which carries no meaning, and it works like a gerund in English. So it's basically, one way to read it is it's the ing in shouting or the ing in drinking, right?
It's more, isn't it more like a phrasal verb though, Rodney? It's more like the difference between shut and shut up or shut in.
No, it's literally like ing.
Okay, but okay.
So it's a gerund.
Okay.
It modifies the noun, but sorry, modifies the verb, but it works like a gerund.
All right, thanks. I have also requested Xiujun to update the table and put more examples. So the archive version, the paper version, will have some more examples and some more discussion.
Yeah.
That.
Just one other thing to add there as well is that particular character, I believe, is somewhat old-fashioned. So a modern translator may not even something like Spacey may not even pick up the nuances of the use of that character, because there are more common characters that serve the same function. So I expect it would miss it.
Yes, and I will take another question or comment from the floor if somebody has. Then, okay. So that kind of brings me to say a few things about some future work, which we would like to do in our group, because firstly, Mandarin Chinese is the largest spoken mother tongue in the world. And this has kind of, our group has done this kind of work for, it's published in the Natural Language Processing Journal, which is on Sanskrit language. So that's what we did last year. And that's a paper published. And this is kind of building up on that work. And the Sanskrit language is one of the least spoken languages, but it has a long, huge corpus of text, basically, as Hinduism's key texts are all in Sanskrit. So there's a huge philosophical library of literature, and some of it is sacred. And some of the oldest works in the world are in Sanskrit. For example, the Mahabharata, the Ramayana, written 2,500 to 3,000 years ago. And the Vedas, which is predates 3,500 and more years ago, and there's ancient Sanskrit there. So it's that evolution of the language. And then in that, we looked at the Bhagavad Gita, which is not classical Sanskrit, but more modern Sanskrit, 2,500 years ago. And it's spoken by less than 10,000, 100,000 people. But there's a huge academic movement in India to restore. And so was our investigation about how to translate it into English and how well Google Translate does it. We have followed up on that work, and we have kind of moved in that framework, and we've included Hindi and Google Translate, Hindi, Telugu, and the Bhagavad Gita and that's a ongoing work. And that is basically where we are also comparing it with Google Translate with ChatGPT and Gemini. So that will give us some more insights on how it is. Low resource language is one issue, but then the issue is that we are looking at the Bhagavad Gita we were looking at. So we are a bit biased because the Bhagavad Gita is a tough book of work. It's a philosophical poem, and poetry is also difficult. There's a lot of metaphor, and we have done some more work on metaphor detection on the Bhagavad Gita and the Sermon on the Mount. So it's kind of difficult for language models. So we thought we would kind of move a bit into actual more recent novels. So Tamas, which is a 1950s novel, we moved into there, and we'll get that work sorted out and in archive by the end of the year. And related to it, we have another work which will be pushing it onto archive in the next few weeks, which is applying this to another low resource language, which with help of Eka there, and that's the Georgian language, right? So we are comparing ChatGPT, Gemini, and Google Translate for the Georgian language translation. And this project, so we are going into various types of languages, right? One is we're looking at languages spoken by a lot of people, but still considered low resource language. And the definition of low resource language is more about what material is there that helps in the translation from one language to the other. Just because the language is spoken by a lot of people does not mean it's a high resource language. And probably Mandarin, although it's spoken by the most mother tongue people in terms of mother tongue, more than 1 billion people, and also Hindi, they would be on some definition considered as a low resource language. And so that brings us to Hindi, and also to these projects, how we are going to proceed is because we've been considering more of the text, the Tamas, which is 1950s, and also the text, the story of IRQ, which is also 1920s. We need something which is more recent. So, and that was our goal in this project, but we couldn't complete it, was to apply it to recent Mandarin newspapers and see how the translation, because Chinese newspapers are translated by experts in English, and we wanted to check how that how these language models are done. But that will be a future project, and then we can compare GPT and other models and see how well they do. So there's a lot of this is a whole research theme of its own in large language model for evaluation of language translation, and it has this quantitative things, aspects where we have semantic and sentiment analysis, and then the qualitative things where we can bring people from the humanities, language experts to evaluate things in a better way. So it's just a small theme that we have started here at UNSW, and we would like to grow it further. That's all I wanted to say. Thank you. Any other questions or comments? All right, so we'll end the recording. Thanks, everyone.
Okay, thank you.